Hello, my name is Dan Miller. I work at Unity Technologies on the PolySpatial team. And today I'm going to be talking about getting started building for the Apple Vision Pro, specifically with Unity. I did want to say a couple things first at the start of my talk, just to kind of set the stage a little bit, and then we'll dive into kind of the agenda here. So first, I can't personally grant access to Unity's Apple Vision Pro. I strongly recommend applying on the website unity.com/spatial if you haven't yet. It is currently a closed beta program, but we are, letting in more participants and things like that. And you can go ahead and submit your application there. On that note, I can also not personally grant access to Apple Vision Pro developer kits. That's all managed through Apple, and they actually have a specific portal on their developer site that you can apply to work with them, get access to developer kits, and they're also doing in-person labs at specific locations around the world. And this gives you the opportunity to go in, work closely with them, work with the hardware, as well as test your applications. So I strongly recommend doing that as well. There'll be a couple of questions I can't answer, just depending on what they are. I'll try to answer everything to the best of my ability. And then lastly, some things are subject to change. This talk is really about kind of our current support for Vision OS through Unity. And we're working hard to enable more features as well as kind of build up the support for everything that's available on Vision OS. So with that, let's go ahead and dive in. And first, what I want to do is kind of talk a little bit about a variety of different topics and how we're going to kind of set the stage here. So first, talking about spaces, and this is really understanding some of the core features on Vision OS so that when I talk about how we're supporting them in Unity, you really understand the different kind of terminology and things like that. Then we'll dive into VR versus MR, how we're actually get started building with Unity, this new technology we've built called PolySpatial, input, and then finally, how to get started today. And this will cover whether you have access to the beta or not, talking about some of the samples and things that we're shipping, as well as how to leverage existing Unity packages and features that will work on Vision OS. So first, let's talk about the building blocks of spatial computing on Vision OS. And how Apple defines this is through two different contexts. So one is the shared space, and this is really the default space that apps launch into. And it's really about having multiple apps. So you can have different windows or volumes. So basically 2D with some depth or volumetric, so like a cube. And these can exist all around the user. You can open up multiple apps. You can multitask, whether you're, browsing Safari, playing a game, and, sending off an email. These kind of exist all around the user. The users themselves can actually move and reposition these apps all around them in their space. So a couple things to keep in mind is that the apps themselves don't know where they are relative to the user. So you can't actually have a piece of content within an app that exists in the shared space to kind of like turn and look at the user because they themselves are kind of self-contained and don't know where they are relative to the real world. There's no ARKit data available for apps that exist in the shared space. So I'll talk a little bit more about what ARKit data is available on Vision OS. But for apps in the shared space, they don't get access to it. So this is things like tracked planes or tracked images. And lastly, you can only use the spatial tap input for apps in the shared space. And I'll dive into this a little bit later with what types of inputs are available. But for now, keep this in mind when considering these types of applications. On the opposite side is an immersive space. And you can think about this as kind of full screening an application, where the shared space might be like a desktop where you have, multiple windows. An immersive space is really a single application that takes over your entire space. So if you have other apps available, they'll kind of fade away and you're just focusing on a single app here. Now, in the immersive space, there's actually three styles of immersion. So first is the full style, and this is what you can really think about as virtual reality. All the content you're looking at is virtual. You don't see the pass-through video, and you're just interacting with that content. Next is the mixed style, and that's what you're seeing here in this GIF on the right. And that's allowing you to look at the pass-through video or really look at the real world and interact with it by placing virtual content in it. And lastly is progressive. And this is kind of like a style on mixed where you're in the real world, you can place virtual content, and you also can supply a skybox or some 3D content that is managed by the users themselves. So maybe you're watching a certain type of immersive video and you can provide an additional level that then the user can use the physical dial on the device to kind of control the level of immersion that they want. Some things to consider for apps existing in the immersive space is you do get access to ARKit data, and this is with special permissions. So you can place content on different surfaces. Here you're seeing the user interact with a plane, in this case, the wall, and have it procedurally spawn some content. You can also do things like image tracking, as well as meshing. The other thing to keep in mind is that apps can actually transition to an immersive space. So you could have an application that maybe has a main menu or a small piece of interaction in the shared space. And then when the user wants to engage more deeply, they can actually open up an immersive space and vice versa. You can go from an immersive space back to a shared space, etc. And so I think, for me personally, really thinking about this transition, thinking about what space the app exists in is how you're really going to be able to leverage or take advantage of some of the unique features of this platform. So now let's talk a little bit about virtual reality versus apps that exist in the mixed and shared space. So at Unity, what we've done is we support virtual reality, which, as mentioned, is a full style immersive space using something called metal compositor services. And so this is basically rendering a metal texture stereoscopically. And you still get access in virtual reality to the ARKit features. So things like ARKit tracked hands, device position, planes. And if you're using the universal render pipeline, we also enable foveated rendering. Now, if you've developed virtual reality in Unity for other platforms before, this should be a really familiar workflow. On the opposite side, when supporting and building applications in Unity to support the mixed or shared spaces, such as immersive spaces in the mixed and progressive, as well as volume and window content, we've built a new technology called PolySpatial. And with this, all content is rendered with Reality Kit. And so there's some caveats and things to consider with that. There's also just some kind of platform limitations to think about. And lastly, you still get access to ARKit data like tracked hands, etc., when in an immersive space. So for virtual reality, as mentioned, it should be a really familiar workflow, and a lot of your content should kind of just work. Because we're rendering in metal, things like custom shaders, particles, etc., should render fine if they are supported on the metal rendering API. You also get access to things like AirKit data, hand data, and more complex interactions, leveraging existing packages that are available on Unity. So for AirKit data, that comes through AR Foundation. For AirKit hands, that actually comes through the XR Hands package. And then for interaction, you can use the XR Interaction Toolkit. Some things to consider when developing virtual reality content for visionOS is this is really a hands first platform. So if you have an existing virtual reality app that uses controllers, you really want to think about kind of, how can you transfer those interactions or how can you build this kind of hands first experience, whether that's, thinking about kind of redoing some of the interactions or just leveraging what's possible with just hands rather than buttons on the controller. Next is thinking about the spatial tap input versus fully articulated hands. And again, I'll talk about this a bit more when we dive into input, but this is this concept of, using the kind of gaze and pinch gesture versus looking at the full joint data that you get with ARKit hands and when to use that and where. And this is probably a bit of a stretch, but if you have an existing virtual reality app that you want to test that it'll work with visionOS on the virtual reality side, you could potentially build a kind of 2D version for Mac OS or iOS, and that'll let you check things like custom shaders and effects using the Metal rendering API. So now I want to talk about building for mixed and shared spaces, and really this is how, or this is why we've enabled and built PolySpatial. So, at a high level, PolySpatial allows you to build a Unity application that has kind of this simulation layer. So, gameplay logic, physics, asset data. And then we transfer that over to the platform itself, in this case, Vision OS. And then we leverage Reality Kit and AR Kit to kind of consume that data, build up the content that you have in Unity, and then also send some of that data back to Unity so that you as a developer can use those APIs to target some of that custom data. So whether it's things like input, AR data, etc. And because when leveraging Polyspatial, everything is rendered with Reality Kit, there's some additional kind of caveats or things to consider. So Reality Kit itself is really, at its base, is kind of a PBR based solution, so physically based rendering. And they have a lot of really good technology in order to kind of seamlessly blend the content in with the real world. On the Unity side, what we do is we enable using the built in render pipeline standard material or the universal render pipeline lit material and map those textures directly over to a Reality Kit physically based material. So you can see here in this visual, I have a material set up for this vase. It has a base map, metallic, normal. And then on the right, this is the Apple Vision Pro simulator. And here we can see the vase in this kind of museum environment. We can actually change the lighting, and you can see the lighting adjust a little bit there. And what this does is just kind of, take into account the lighting. It also takes into account the real world. So it'll build up this kind of dynamic IBL or cube map that updates as the environment changes and really blend that content in. Now, if you're using custom shaders, we leverage something called Material X. And so this is actually a kind of open standard for node-based shader creation. And Reality Kit can actually consume these Material X graphs and render custom shaders. So on the Unity side, we support this by enabling our node-based shader graph editor and translating those over to Material X and then supplying those to Reality Kit for custom shaders. So if you want custom shaders in PolySpatial or on Vision OS, then you'll need to use Shader Graph to author those. Now, there are some nodes that we don't fully support, but we're working hard to support all the nodes that is available within Unity Shader Graph to enable those for custom shaders on Vision OS. Now, ARKit specifically, if you're familiar with ARKit for iOS, Apple's actually made a specific version of ARKit for Vision OS. And on Unity, we enable this through AR Foundation. So AR Foundation is our abstraction on top of a variety of different AR platforms to really give you a single API that you can target for building to these platforms with specific features. So we have something that's called AR Plane, and that works across a variety of devices and platforms that provide AR Plane data. So for Vision OS, ARKit features need to be enabled with permissions. So there's a world sensing permission for things like plane detection, scene geometry, which is meshing, as well as image tracking. And then there's a specific permission for hand tracking. And this gives you access to what we call the fully articulated hands, or really the hand joints specifically. So the available AR features for Vision OS are device tracking, anchors, plane detection, scene geometry, image tracking, and hand tracking. And something that I found is really interesting, as well as a really kind of fun thing to leverage or take advantage of in applications, is those semantics that come with both plane detection and scene geometry. So that gives you the ability to kind of understand different parts of the environment. It'll label things like plant, ceiling, wall. It can also do things like window, etc. And then you can have kind of unique interactions depending on the surface and how it's been defined. Next, I want to talk a little bit about the volume camera. So this is a specific component that we've built in PolySpatial to enable some of the features on Vision OS. So the volume camera is really what enables what sort of mode your app exists in. So in the camera mode, we have bounded and unbounded. And so bounded volumes are really apps that exist in a shared space. So this is something like a volume. And then unbounded is how we enable the mixed immersive space. So, what that means is you can actually have a single application that has one scene that's in bounded and another scene that's in unbounded. And when you load that second scene, it'll kind of transition into that immersive space, and vice versa. You could load back to that first scene as well. On the actual volume camera itself, we have some dimensions and then we have an output configuration. So, this configuration is you kind of defining all the different sizes and the different types or modes of volume cameras that you want within your application. So, these are little scriptable objects that contain this data, and then you can reference those directly on the component. So the dimensions of the volume camera is really the size of the volume in Unity space. And you can see this kind of green gizmo that we actually enable within the scene view. And then the output dimensions is the size of the volume in the real world, how it kind of builds itself on the Vision OS side, or in this case, the Swift UI side. Now, a couple things to consider for bounded content. So, again, this is content existing in the shared space and how you can actually interact or think about things with the volume camera. So the volume camera itself, again, kind of defines this, volume of content or this space at which the apps can exist. And you can see on the far left, if we translate or scale those kind of dimensions, you can actually see the content move throughout the volume. So in the shared space, the app exists or the volume exists there wherever the user puts it. But as you move the content or the volume camera on the Unity side, the kind of content going through it can be manipulated, whether it's translation or in this case, we're actually scaling down the rendering. Another thing to keep in mind with bounded content is there is a hard clip at the edge of volumes. So you can see here in this center example with the sphere or the globe, it actually clips right there at the edge. Now, this is an opportunity to do something like, show back faces or have a special rendering effect, but it's something to consider where, when the users are interacting with content and getting kind of near the edges of the volume there. And then last but not least, I think, really considering, what is your application doing? What sort of interactions and things take place within the shared space? So, the user could be, responding to an email, watching a piece of content, and then have your app up as well. And whether that's some kind of light passive interaction or, what sort of experiences they can have, I think you should really think about that because apps that exist in the shared space will probably exist alongside other apps as well. Now, for unbounded content, or this is content that exists in the immersive space, it does leverage a lot of existing Unity paradigms with things like an XR rig. So you have like a tracked pose driver, which will then translate over to the device position. In this case, the headset's kind of position and rotation. And similar to virtual reality, you can enable a lot of the familiar features from other XR platforms through the packages that we already release. So ARKit data comes through AR Foundation, hand data comes through the XR Hands package, and interaction or more complex interaction can be enabled with XRI. Now let's talk a little bit about input. So input on Vision OS is a really kind of unique part of the platform that enables some really interesting kind of input paradigms. And one of the kind of key pieces of input that I've mentioned before is this spatial tap. And what this is this allows the user to look at a piece of content and then use a pinch gesture to actually make a selection. While this pinch gesture is maintained, this kind of input is maintained. And so you can do, certain translations and things like that. And the gaze and pinch is considered an indirect pinch. The user can also directly pinch on content, as well as touch or poke content to interact with it as well. So we enable this on the Unity side through something we call the spatial pointer device, which is enabled in the input system package. And there's a lot of conditional data that you get while this input is maintained. The most important pieces of data are probably the interaction position. So this is the position that the interaction actually takes place at. The device position and rotation, the interaction kind, which is going to be the differentiation between, direct pinch, indirect pinch, poke, and then the target object. So you actually get the object that you're interacting with. Now, the interaction position is really where you're looking at on the object when the input is actually initialized. And while you kind of maintain this, you'll get a delta from that initial position. A couple things to keep in mind is inputs only happen on colliders. So this is true in the polyspatial side of things, so in the shared space or mixed reality. And what this means is that if your object doesn't have a collider on it, you won't be able to get input and you won't register input. So there's no concept of kind of an ethereal input where you're not looking at anything and you start to register things, at least on the spatial tap side. In this case, the device is actually equals the pinch position. So where you're kind of moving this pinch around, you'll get updates relative to the device position as well as the rotations. You can kind of grab objects and then inspect them and things like that. The interaction ray is the gaze vector, and this is really only available for a single frame that the input is registered, as well as only available in the immersive space. And lastly, some of the data similar to that interaction ray is only set in the began phase. So it only happens for a single frame, and then it basically stays that data, while some of the other data, like device position, interaction position, is updated as you maintain the input itself. So how does this look on the code side? So in this case, we're actually enabling the enhanced touch support to get the proper pooling API for active touches. So we can do this in the on enable. And then here in the update, we'll get the number of active touches. And if it's greater than 0, so a touch is active, then we can actually use this static method to get the pointer state passing in one of those active touches. And so here we're getting the primary touch data, and if we're in the began phase here of the active touches, then we get all the access to the data that I just mentioned in the previous slide. So you can get the interaction kind, the actual object that you're, looking at or interacting with, as well as things like the interaction position. On the other side, there's also access to ARKit hand tracking. So ARKit hands are available only in the immersive space, and it gives you access to really these articulated joints. So you can tell, where the user's index finger is, where their thumb tip is, etc. And you can start to kind of calculate custom gestures or really do any sort of logic relative to the user's hands themselves. A couple things to consider is that this joint layout does not conform to the OpenXR standard. So there is, some different joint naming and things like that, as well as the rotations themselves. And by default, your hands actually occlude the virtual content, but there is an API to kind of enable or disable this. So if you've used the XR Hands package before, you can actually get access or use the same code and same logic to get access to AirKit hand data and these articulated joints as well. So basically, you can subscribe to the hands subsystem, which has an update hands method. And then from there, you can link into the success flags and call or check the success flag specifically on hands. In this case, we're checking the kind of right hand pose to make sure that it's tracking. And then from there, we can use the subsystems right hands to get data to specific joints. In this case, I'm doing kind of a custom method here for actually detecting a pinch. So I'm getting access to the right index thumb tip joint and the right index tip joint and the right thumb tip joint. And then I'm just calling this detect pinch method, which basically gets me the pose of both of those joints. So that's what contains the position and rotation. And then we can just do a small distance check between those, that if it's crossed a threshold, then we just instantiate an object. So this allows us to kind of pinch with both hands, instantiate objects relative to that user's pinch based on doing a distance check between it. And this is how you get access or do a kind of custom pinch on other platforms that are supported with the XR Hands package as well. And lastly, I want to talk a little bit about the XR Interaction Toolkit. So this is something that we're still working on enabling, and we're really approaching this from a couple different ways. So first is a custom interactor. So we're calling this the XR Spatial Pointer Interactor. And this actually leverages that spatial tap and allows you to kind of position itself as an interactor relative to the objects that you're looking at or interacting with. So you can do things like direct or indirect pinch, and then it'll put that interactor on or relative to the object itself. So then it can be kind of picked up and managed then through the XR interaction toolkit. So, you can have things like grabbables, apply certain like physics properties and things like that. The other thing we're doing is enabling button controls. So if you're familiar with XRI currently, it uses the input package in order to enable all of these different kind of control states that then fall back to different types of controls depending on the platform you're on. So really, we're trying to enable this to enable existing applications that leverage XRI so that it can feed into those existing bindings. Now, right now, we're looking at leveraging kind of the spatial tap gesture as well as ARKit hands. So you could kind of leverage or use both of them. One of the big challenges with this is that existing XR platforms as well as XRI specifically really relies on handedness, and the spatial tap gesture does not contain handedness. So, if you are looking at a piece of content and you trigger here, this will be kind of the 0th index. You let this go and then trigger with your other hand, that'll also be the 0th index. So there's kind of no handedness relative to the tap gesture. And XRI really kind of leverages things like left hand, right hand. So that's kind of one of the challenges that we're looking at with the kind of button controls. And lastly, I wanted to mention this hover component. So VisionOS does not provide data to the developer or to applications when you're actually looking at content. So it never provides eye tracking data. It never provides gaze data, except for that one, frame of interaction when you're actually doing an interaction. And so they do have a special component called a hover component. And so we've enabled this in Unity, and it allows you to attach a custom component to any sort of object that has a mesh renderer and a collider. And what this will do is this will actually highlight the object to the user as they're looking at it. Here I'm in the VisionOS simulator, and you can see me kind of going between, and you'll see this light hover effect that applies to it. So some things to consider is it only works on colliders. So this is similar to input. And that means that complex collider setups might not properly translate it. So if you have an object that has multiple colliders on it, make sure that there's some collider that's relative to the actual mesh renderer in order to properly enable this component. All right, so that was a lot of information. And now I just kind of want to dive in and talk a little bit about getting started today and what you can do as a developer if you're interested in building for VisionOS. So today we've actually enabled the VisionOS build target in Unity 2022 LTS. So this is available in the latest version of the 2022 LTS. And this is what we're thinking about as kind of windowed mode or compatibility mode. So you can build an existing Unity application, whether it's a mobile game or a full 3D game, and target the VisionOS platform. And this will build in this kind of windowed mode. So here we're actually seeing an image of Boat Attack, which is a 3D game that's kind of being played here on this 2D slate within VisionOS. So you get access to input using the kind of existing Unity input paradigms like input.touch. Now, if you want to enable more of these volumes or immersive spaces and things like that, you need access to the PolySpatial packages. And so that's currently in closed beta, but that's how we enable these kind of more rich features within VisionOS. And lastly, if you want to develop a full immersive space or a VR application, you also need access to that beta, and that's available using the VisionOS XR plugin. That is also an additional package that we're shipping. Now, something that we're distributing with the PolySpatial packages is the template. So this is something I worked on, and it allows you to interact with content here in the bounded mode. So here we have some kind of light, playful physics interactions. You're able to, directly or indirectly grab these objects, move them around within the volume itself. And then you can actually hit that expand view button and go into an unbounded mode as well. And so here we're kind of seeing that. And then we have some, kind of UI that you can then click through and learn a little bit more about the project. Now, this is something that we're shipping with each of the package releases as well as updating. And really, it's meant as kind of a lightweight starting project that's pre configured with all the settings and things like that. The other thing to mention with the template is we currently are really targeting PolySpatial. So it doesn't currently cover any virtual reality features or really just the setup for a virtual reality app for Vision OS. The other thing that has been really my primary focus is getting started with these samples. So, with the polyspatial packages, we're actually shipping samples alongside the package that you can import into your project. And it has things like a project launcher to go through and select a variety of different scenes. And some of these scenes are really trying to showcase, how do you use input? How do you take advantage of some of the features? What things are supported? What are some kind of best practices and things like that? So in the middle there, you see there's this object manipulation scene to kind of grab and stack some little cubes. And then on the far right, we have like balloon gallery, which you can either use an indirect pinch, so you can kind of look at the balloons and start popping them, or you can actually use the direct pinch or the poke to pop those as well. And so these are shipped as open source. You can look at the different scripts, how the objects are set up, and things like that. And it's really just trying to help, kickstart your development and really get started quickly. Now, the other thing I want to mention is that while the polyspatial beta is currently in kind of a closed beta, there's also lots of existing packages and features and things we have at Unity that will basically just work on Vision OS. And that's what I've been mentioning with the supported packages and how we've kind of enabled that through existing packages and features that already are out there. So one of the big ones is the XR simulation within the Unity editor. So this is enabled through Air Foundation. And this visualization that you're seeing on the left is actually one of the samples that we ship for mixed reality. So what it does is it goes around and builds up dynamic planes as well as a mesh, and then adds these little labels to each of the surfaces that describe the kind of semantic data that I mentioned earlier. And again, this is a great way to kind of test ARKit features, start getting started with some of the gameplay logic, as well as things like that. And you can do it directly within the Unity editor without access to PolySpatial and without access to a dev kit as well. Next is the XR device simulator. So this allows you to kind of use WASD controls again within the editor. We're also supporting different hand gestures as well, which will then kind of fall through and leverage those XR hands kind of articulated joints so that you can add some custom gestures and logic for that too. And then lastly is the hands interaction demo. So this is a demo that we're shipping as part of the XR interaction toolkit, and it leverages articulated hand tracking on other platforms and allows you to kind of directly or indirectly interact with content, as well as do things like two-handed gestures and things like that as well. And again, these are kind of packages, features, things that exist in outside of polyspatial that will work on Vision OS because we're leveraging those same kind of packages. And lastly, I kind of want to end with just some kind of general getting started. If you're thinking about building a project or you're thinking about porting a project over to Vision OS, these are kind of the general guidelines as far as packages, what sort of versions, and really just some kind of strong recommendations here. So definitely check out the latest Unity 2022 LTS, the Air Foundation package, XR Hands package, XR Interaction Toolkit. We strongly recommend using the universal render pipeline. This gives you access to things like shader graph, as well as foveated rendering on the full immersive space or VR side of things. The input system package for enabling the kind of spatial tap gesture. And then really just, I think this is going to be kind of one of the more heavier kind of technical lifts, but think about porting a lot of your shaders over to using shader graph or leveraging, a fully, let's say, PBR physically based rendered game using a lot of standard shaders. And lastly, a couple, final things to consider is thinking about kind of abstracting input, whether you're building a cross-platform application or just targeting the Apple Vision Pro. I think you should always think about, how your input feeds up and what sort of data that's possible on certain platforms and how that's kind of surfaces itself. really be creative with the platform constraints. I mentioned this a little bit earlier about the different kind of modes and transitioning between the shared space and immersive space and back. And I think that creates a really kind of unique opportunity for apps to take advantage of that. And then lastly, use existing simulators, emulators, devices. The Apple Vision Pro and our support with PolySpatial, is kind of a unique package itself. But a lot of these features, packages, and things exist on other platforms, and so there's ways to kind of get started thinking about what might be possible and how you can kind of filter this out and start building applications today. And with that, I'm all done. Thank you.
Very, very cool. I'm still gonna annoy you about getting a headset, but that first slide, you said you weren't gonna do it, but no, actually the thing that popped to mind when I was kind of watching Vision OS introduces this concept of shared space. This is maybe a weird question for you, but will if one Unity app developer builds something that goes into shared space, could their app interact with another Unity app within that same shared space? Could you have your video game characters essentially emerge in that shared space and like fight other video game characters?
Yeah, I mean, out of the box, apps do not do not what we'll call like send data or know about each other, just like the calculator app doesn't know about your web browser.
Mhm.
But there's really nothing stopping you as a developer from you know basically sending data to other apps or kind of making that connection. So potentially someone could build an application that does that, or really build a framework that kind of lets apps talk to each other. But out of the box, it doesn't. But there's certainly nothing stopping it there as well.
Yeah, that would be a pretty neat feature of Unity to kind of create like a shared space mesh that these apps could talk through to each other. So
Hmm.
I'm not making any feature requests though. This is just I'm just throwing ideas out there. A person asked this question. I'm not entirely sure if I understand it, but maybe you will after I read it. Can we know how transferable particle systems are in the mixed space? I'm not
Yeah,
entirely sure what you mean.
yeah. No, it's a good question. So I think the question is really particle systems. So this is something I didn't really touch on, but as mentioned, when you're in the mixed immersive space as well as in the shared space, everything is rendered with reality kit. So
Mhm,
reality kit actually has their own particle system. Unity also has actually a couple particle systems. And so currently we are transferring some of that data over. So we have a Unity particle system, in this case for Shuriken, and we translate that over to the reality kit particle system. Now, there are some differences and some things we're working through with that. So, certain modules within Shuriken are not going to work in reality kit, and we have some documentation on, what's supported and what's not. And we're also building up and exploring a kind of more robust solution for particles in those spaces. So it's a good question. It's a little bit of a TBD. We're trying hard to kind of support that, but that is a certain caveat or something to really think about or consider when porting to Vision OS for sure.
mhm. Okay. I think Fedor has a good question that he just picked out. Fedor, go ahead.
Yeah, we have a question that are blend shapes supported in the latest version of the package?
Blend shapes are not supported. So currently, blend shapes are not supported in Reality Kit. And so while blend shapes are supported in Unity, when we're rendering or leveraging PolySpatial, we have to kind of take advantage of some of the platform specific features. So not yet supported. I do want to do a small call out if there are features like this, or there's certain things where it's not yet supported or you don't kind of see it there. And it does end up being a little bit of a platform limitation. I strongly suggest, reaching out, submitting a feedback to Apple. They're also really eager and excited to hear what developers are looking for. So, they have the feedback assistant. They also have these kind of in-person labs and stuff. And so definitely reach out and ask them about that. So, but currently blend shapes are not supported, but that's also a good question.
Okay. I guess a question for all the Unity devs out there that may have VR or AR, applications out there. From your experience, kind of seeing, uh, you know, the interaction between Unity and Vision OS, do you think they'll have an easy path to transition their applications over into kind of the Vision OS space?
Yeah, I mean, that's certainly our hope or goal. I think again, it really, unfortunately, there's no easy answer, as every application is just so different and unique, and so it kind of depends on what features their application uses or things like that. I will say on the virtual reality side, I think there's going to be a much easier path since we can leverage those metal compositor services. A lot of things like particles and custom shaders should mostly just work. When you're
Hmm.
starting to take advantage of using PolySpatial, that's when I think there's going to be a little bit more of a kind of heavy lift or a technical challenge, especially with things like custom shaders.
Hmm.
The nice thing is if you have an app today that leverages ARKit for iOS and uses AR Foundation, a lot of that logic should mostly just work. You're placing content on a plane, it's doing something relative to that plane or surface. You're say, hey, this is a wall, put a picture frame on it. That stuff's really just going to work the same because it feeds through that same kind of abstraction layer at AR Foundation.
Hmm.
So,
Yeah, our chat saying things like, "Love that there's so much to explore in this space." Between what Unity's bringing, what Vision OS is kind of bringing to the table. Yeah, it's super exciting. I'm looking for more questions here. See if a lot of people are trying to get into it again. Just to reiterate, what the website is for sign up. I think it was like
yeah, so
create. Yeah, go ahead.
unity.com/spatial.
Hmm.
And I know lots of people are excited to get in. We've also know that there's lots of applications. It is kind of a rolling basis. So we are, as we're scaling up some solutions on our side, we're trying to get more people access. We're also really eager. Um, we want people in the program, and we know there's a lot of people to get excited about and start building, and so it's something we're constantly looking at. We're constantly trying to let more developers in. So the main answer there, unfortunately, is kind of just be patient, but you can certainly start thinking about some of these existing tools and things as well.
Hmm. Well, I guess one more question for you, like seeing kind of like all the AR, VR platforms that are out there and the ones that developers are targeting, is there something in your opinion that kind of makes Vision OS kind of stand out, or might something that maybe developers want to take advantage of specifically on Vision OS compared to maybe some of the other platforms out there?
Yeah. I mean, I don't want to do any direct comparisons or things like that, but I will
Hmm.
say, Vision OS itself being this, full kind of operating system and things, I think the shared space is really this kind of unique and unexplored opportunity for, applications to potentially have multiple kind of modes or things that you're enabling there, as well as just like starting to think about what sort of user behavior might exist there, where if you think about other platforms, you launch basically a single application, you're in the application, you're really kind of focused on that that core application or that single application. And with the shared space, I think there's opportunities for users to kind of fill their space with all sorts of virtual content, whether that's a virtual bonsai on one side and a virtual cat on the other, and really just kind of giving users access to a lot of different kind of unique experiences, and then having like different layers of interaction within that. So
Hmm.
that's personally something I'm really excited about. Just kind of like all these little apps and volumes and things existing around me.
Yeah, it's funny because when you were showing your sample that you built, I was thinking to myself, like, you single-handedly killed the desktop fidget market instantly, right? Like, no one's gonna have anything physically on their desk anymore. So it's gonna be these virtual widgets and stuff like that. But no, this is super exciting stuff. So again, thank you to you, Dan. I know I won't be getting the headset, but you said it in your slide. You can't do that. I get it. But if folks are interested, please go to the website that Dan talked about. It seems very cool. I think a lot of Unity devs can get a lot accomplished in Vision OS. So I'm excited about that. Again, thank you, and we'd love to have you back. Hopefully, when Vision OS and the headset gets released,
For
it'd
sure.
be a nice
Yeah.
box.
And thanks for having me.
Yep.
Thank you, Dan.